Good afternoon, viewers. On behalf of the Pacific Battleship Center, thank you for joining us for today's very first webinar book talk. I'm David Way, the curator and historian of Battleship IOWA Museum at San Pedro in the Port of Los Angeles. We're a nonprofit organization with a mission focused on education, veterans, and the community, as well as being, of course, the custodian of Battleship IOWA herself. Today's presentation is being recorded to be played later on our YouTube channel for those individuals that could not participate today, or if you'd like to review this presentation at a later point in time. The last 15 minutes of this hour today will be devoted to answering questions that you may post by clicking on the Q&A icon at the bottom of your Zoom page. And you can post these questions anytime during our presentation today. With us today is Professor Thomas Heinrich, Chair and Professor of Business and Naval History at the Baruch College in New York, author of the newly published book, Warship Builders, an Industrial History of U.S. Navy Shipbuilding, 1922 through 1945. This book has been published by the United States Naval Institute Books Press, and currently, during the whole month of September, all of the Naval Institute Book Press books are 50% off, and they also have free shipping. Now, you can also purchase the book at normal book outlets and retailers such as Amazon, Barnes and Nobles, and even eBay. I've noticed they were on there. I've purchased or ordered my book, and I'm anxious to receive it. I was really excited to see this book come out. It covers a subject matter that should have been covered a long time ago and has only been lightly brought out, the information that I know is probably in the book. So with that, let's kick off and have some what I call ship talk. Good morning, afternoon, excuse me, Herr Professor. I would imagine this took an enormous amount of research, conducting research myself. And what inspired you or led you to kick off this campaign or effort to produce this book?
Thank you very much for this kind introduction, Dave, and thank you all for coming on a Friday afternoon. So as far as kind of the impetus behind this book, well, first of all, it's the fact that nobody has really written much about naval shipbuilding in the course of the Second World War. So that's one aspect. I do have an interest in things maritime. I come originally from a northwest German seaport town called Brunsbüttel, at the confluence of the North Sea, the Elbe River, and the Kiel Canal. So, we were pretty much surrounded by water. But in any event, I did my undergraduate work at the University of Bielefeld in Germany, and then over at SUNY Buffalo, I did my master's degree. Went on to do my PhD at Penn, and that was really the point where I got pretty interested in industrial history. And what I really mean by that is the aspects that really make American industry, or really any industry, tick, right? And that is design, engineering, production, and in particular, workplace skills, right? So, those have been really themes in my own work, really since I did my PhD at Penn, and my first book was actually on the shipbuilding industry in Philadelphia. I always wanted to do another book, because I think shipbuilding does bring together a lot of these things that I'm interested in, right? So I started off, I said, I'm going to do another book about Philly. And then I said, I might as well try to sort out what are they doing up in Massachusetts? What about Virginia? And then I was like, you got to look at California too then, right? So in the end, make a long story short, it turned into a 10-year research project, including, pretty substantial comparative aspects of not just American shipbuilding, but British, Japanese, and German. So that is kind of how this Philly study ballooned into something that was just, um, uh, just uncontrolled project but in the end, I of course brought it to a more or less successful conclusion, and you have it in front of you now.
So that was probably several trips to the National Archives, to say the least.
I lived down in Washington, D.C. at the National Archives. I spent a lot of time really at various archival collections, at the UK National Archives in Britain near London. I was over, in Germany, spent a lot of time there, in Scotland, in the United States here. I had done a lot of work actually in Philadelphia, in Boston. I did some work, of course, here in New York City and, in Brooklyn and all of that. Yeah, so a lot of this is really archival stuff. And
so it's partly a labor of love and a great passion and interest to produce one of these books.
But this is what we academics get paid to do, right? I mean, to kind of, write things that a lot of other people are paying attention to. Yeah,
sure. From our previous conversation, we had talked about most individuals, when they think about the major shipbuilding efforts that took place during World War II, they usually think about the Liberty and Victory cargo ships that were led and produced with the Kaiser efforts. But we were noting that building warships is a much, much more complex endeavor through all kinds of challenges.
Yes, actually, if we want to go to the next slide here, because that illustrates some interesting points related to that. Yes, so what you see here is actually the Kaiser Shipbuilding organization up in Oregon and Portland, and so this, in so many respects, kind of encapsulates the story of industrial mobilization in the United States. I mean, whatever you do in your textbooks, you always read about Henry Kaiser and his Liberty ships. You will also read about Henry Ford and the mass production that he did of B-24 Liberator bombers in Willow Run, Michigan. So, these are kind of icons really of American industry. And you kind of already see here in this photograph some of the core characteristics really of Kaiser Shipbuilding. And that is, first of all, design standardization. All of these ships are the same. You look at them. Kaiser, I think, altogether built about 700 Liberty ships. And in addition to that, he built Casablanca class escort carriers, which were really horrible ships. The crews called them Kaiser's coffins. So there's one. Here's another. As far as Henry Ford was concerned, Henry Ford's B-24 Liberator bombers that were built in Willow Run, Michigan, right? They were, the crews called them, will it run? So that kind of gives you a sense of the shoddy quality of a lot of this stuff out of the mass produced stuff, really, that came out of American shipyards and out of aircraft factories. That kind of, it kind of fits overall with the portrait of American industrial mobilization. We built lots of stuff using mass production technology. None of it was very good, but it got the job done. We buried the Axis underneath an avalanche of mass-produced weaponry. Shipbuilding, naval shipbuilding, is really a completely different animal compared to this. That is, compared to a standardized production over the course of the Second World War. And if we can go to the next slide, actually, what you see here is the Brooklyn Navy Yard. And that's, by the way, the birthplace of the Battleship Iowa. But what you see here, where the cursor is pointing, that is the sister ship of the Iowa, that's Missouri. At the bottom, you see the aircraft carrier, that's Bennington. That's an Essex Class aircraft carrier. And, you just see a lot of other stuff kind of afloat in the water. That speaks to the fact that there was very little kind of standardization going on. You did not mass produce battleships. You did not mass produce aircraft carriers by the hundreds. Far from it, right? I mean, these were batch produced. And, as far as the Iowa class was concerned, that was a batch. Originally, they planned 6, then they cut it down to 4. That's not mass produced.
Right. Exactly.
So, important aspect really of this type of production, right? It's design intensive. It requires tons of skilled labor, and we're going to talk about that a little bit later, Dave.
Right.
So I mean, there's very little product standardization going on.
So many of us online today, as you could imagine, are interested in the Iowa class battleships. And I was excited to hear that you devoted about 20 pages in your book on the construction of these ships. And I'm anxious to read all that.
Thank you. Yes. So, I mean, as far as the Iowa class is concerned, I mean, this was really the single most advanced battleship class that the United States ever produced. It was also the last. If you can go to the next slide, let's have a look. Yes, so what we see here is really the evolution of the Iowa class design out of previous classes. So make a long story short, really, as far as American naval rearmament is concerned, for a long time that was restrained under a thing that's called the Washington Naval Treaty that was signed in 1922 and suspended battleship construction in the United States, Japan, Britain, and in other places, Italy and France. But the purpose was really naval arms control. This was one of the great diplomatic achievements, really, of the interwar period in attempting to prevent further arms race, particularly as far as battleships were concerned. Remember, German, British naval competition was a big factor leading up to World War I. So the United States engineered that treaty. For various reasons, then it expired in 1936 and was not renewed, unfortunately, really. But in any event, the U.S. Navy was ready with new plans for a series of battleships that were going to be built. The first one, what they called the post-treaty, the post-Washington Treaty battleship class, that was the North Carolina class we see here up the top. And that was the first attempt, really, of the U.S. Navy to start experimenting with new battleship designs. That was then followed by Alabama. That is one of the South Dakota class battleships. You kind of see these, they're a little bit shorter here, than Washington. And, again, I mean, to some extent, these were guinea pigs, really, for the design of the Iowa class, because they started to experiment with a number of design innovations. Dave, you were going to say something?
Oh, no, I was just going to mention, there was an 18-year gap between, due to the naval treaties, of commissioning a battleship. Mm-hmm. And then also, as you commented too, with the Royal Navy of England and Germany, the countries that spent so much money on their naval fleets, and the public in England was furious. And later on, I think that led to these Washington naval treaties as well. Stop an arms race. Today we think of missile arm races. That day and age, it was warships. And battleships are a pricey commodity.
Absolutely. And, I will say, when you look at one of these, I mean, one Iowa class battleship cost $130 million. That's real money. That's the single most expensive weapon platform built in the Second World War. Right?
And that was $1940. And
that's in $1940.
Yeah. And today, it's really hard to me to figure out without just straight escalation. There's other factors that come into play, and it's got to be, if a Nimitz class aircraft carrier is like $11-12 billion, I would think a battleship is somewhere in that range.
Yes, absolutely, and it was controversial. There were many people who were opposed actually to battleship construction. FDR, the president, of course, was a little bit of a fence sitter, as he was on so many things. But I mean, he was a real naval enthusiast,
Absolutely.
and was actually, for all of these battleships, he picked the names personally, right? And I mean, he loved this stuff. One of the things that he was famous or infamous for was like, he always insisted, as president, on reviewing the construction plans and blueprints for new battleships and for aircraft carriers, and added various little things, like a different bow, or another funnel, drove the naval architects nuts,
I can,
because these things serve no purpose.
right,
They just suited
right.
his taste. But in any event, he was one of the great supporters and proponents, really, of the construction of these ships, right?
Right.
Because he saw them as a way to contain primarily Japan. That's what we're talking about when we're looking at American naval
Sure.
construction during this period. This is really to go after, or to kind of present Japan with a very credible strategic challenge in case they go into Southeast Asia, that is, into the Philippines, Indonesia, and other places. Yeah.
I've seen one individual's name called out in other books and articles that contributed greatly to not only the design of the Iowas, but I believe the Battleship Washington and perhaps South Dakota class
Mhm.
battleships, and that was Captain Alan Chantry.
Thank you very much for bringing up Chantry, because yeah, he's actually a very important figure in this story, right? Because, well, I mean, he was initially as captain. I cover his biography actually in the book, and so he's an interesting guy. He started off in the U.S. Naval Academy with a bunch of people, actually in the same class. Admiral Bowen, or later Admiral Bowen, was in there too. Um, as well as Robinson. And these are sort of very important people in the history of the U.S. Navy. Chantry ended up then at what's called the preliminary design section in the U.S. Navy Department in the 1930s, and that's where he was then responsible primarily, really, for armor design in North Carolina, in the South Dakota class. That was then later on adopted in the Iowa class. Excuse me. Make a long story short, one of his great design innovations was to introduce a sloped side armor, and for battleships, that was really designed to defeat plunging fire. That is, once you're sort of in this new era of 16-inch guns that we'll talk about a little bit later, but once you're in this new era of 16-inch guns, the projectiles tend to land on the enemy battleships at extreme angles, right? And so Chantry kind of factored that into the design, really, of the North Carolina, and then most importantly, really, in the South Dakota class. Later on, again, I mean, that got incorporated into Iowa. But when the Iowa program got underway, Chantry was already at the Philadelphia Navy Yard, where he became the industrial manager, and did oversee at Philadelphia the construction of the battleships New Jersey
Right.
and of Wisconsin,
Wisconsin.
both of
Yes.
which were Iowa class. Yeah. Mhm.
Right. Of course. And I've heard that welding was relatively new when construction of the battleships and other warships in 1940 was started, and that there was a lack of knowledge in dealing with these
Oh, yeah.
due to shrinkage issues and the lack of skilled welders, and that caused some challenges during the initial construction phase east of
Yes.
Iowa.
Yes. If you want to go to the next slide, actually, I think that illustrates that. Maybe, I hope. Let me go to the next slide. No, actually, this is a little bit different, but maybe we can talk about welding in a minute. What this is at the Brooklyn Navy Yard, the design section, right? I mean, so these guys, we can tie that in really with with the welding end of things. But what you see here is naval architects and marine engineers, and they are developing the Iowa class design, which was stupendously complicated business. We're looking at naval architects. About 700 or 800 of them worked for a good 2 million man hours to develop the Iowa class design. That included, you kind of see this here, that's a cross section, right? I mean, mind you, that's a general plan. That's a general plan. I mean, you can't even read, neither can I read the details on this. But so what happens with a lot of these naval architects, they're starting to experiment with new types of production technologies, and welding is one of them. Welding, that is difficult undertaking, really, from a variety of perspectives. The US Navy really pioneered that in the United States. There were not a lot of other industrial applications of welding on this scale. So there was a lot of experimentation that was going on at the time. You had to do the specifications. This is what these naval architects and marine engineers really did as part of their daily routines, right? When they put together these blueprints and specifications. If we can go to the next slide. Can we? Oh no, here are the turbines. It's going to take a little while for us to get to the get to the welding, but no, go back to the turbines. So the turbine engines on the Iowa class, right? I mean, these were real monster engines. They were the largest non-nuclear, or the most powerful non-nuclear engines ever installed in an American combat ship. Prior to the nuclear engines, that come with the 1950s and 60s carriers, right? But these engines produced about 212,000 horsepower combined. So one of these engines would be about 50,000 horsepower plus, right? Mm-hmm. So the core was really these turbines that you kind of see here for the Iowa class that was designed by, actually for Iowa itself and for Missouri, those were manufactured and designed by General Electric, and the two sister ships down in Philadelphia, that is the Wisconsin and the New Jersey, those were made and designed by Westinghouse. So, you can already see these variations, right? I mean, what you see these guys doing here is, they're hand fitting blades on these turbines, right? It's mind boggling that, guys could actually do that to just unbelievable tolerances. They check every single one of these turbine blades with a micrometer to make sure that this is going to be a tight fit against the turbine case, right? So that again speaks to the importance really of precision work, and you're going to not let some green hand that you trained for a couple of days do this kind of work, right? You better know what you're doing with these kinds of complicated, complex, precision engineered pieces of naval architecture, marine engineering. If you want to go to the next one, the turbines, they were actually part of a system, right? Very important to kind of keep that in mind. So when we think about turbines, kind of see this here. These are high pressure turbines, low pressure turbines. When you are looking at sort of the engineering requirements for turbines, right? These things, they tend to run most fuel efficiently at about 5,000 RPM. If you try to put that on a propeller screw, nothing is going to happen. You get what's called propeller cavitation, and nothing is going to move, right? So what you really want to do is put in between the turbines themselves, right? You want to put basically what nowadays you could call a transmission, right? So you have two reduction gears. This is the first one, second reduction gear. What you really want to do with that is you turn 5,000 RPM into 202 RPM. and that's that's a good speed for the Iowa class screw propeller, right? And the Iowa class had 4 of those. So, I mean, this stuff really needed to be precision engineered as well. Kind of when you look at the reduction gear, on the reduction gear, the bigger one here, the first one, that was called the bull wheel. Inside of that's a 200-inch diameter wheel, right? So in order to machine that, you had to do that in a temperature-controlled environment at 67 degrees Fahrenheit over a period of about 17 days. You couldn't stop cutting these teeth, and they had to be cut to a tolerance of about 1/3000th to 1/10,000th of an inch. That's the thickness of cigarette paper. So again, I mean, you want to have guys who really know what they're doing in this department, and who've done it before, and who know how to operate this extremely complicated bits of machinery, right? Yeah, so these guys, I mean, they're machinists, right? And they're really at the top of the sort of craft hierarchy in most of these shipyards, right? These guys, they served 4-year apprenticeships for the most part, and this sort of rule of thumb in shipbuilding was, I mean, you needed at least 10 to 12 years of practical workplace experience to become a good mechanic. And, and those are the kinds of skills that are being brought to bear in the skilled trades in the shipyards.
Great. Can we double back to the welding conversation?
Yes, let's talk about welding at long last. Go forward in the slides.
Because there was
here's the welding. Yes, thank you. Go ahead.
Because I was interested in the story or comment you mentioned on the problem Iowa ran into. I'll let you take off with that.
Thank you. Yes, I mean, this is pretty significant. What you see here is actually welding that was done on the battleship Washington down in Philadelphia. I mean, the process was very similar in Iowa. I just like this photograph, because you see this guy standing up with the cap, who's just sort of standing there and, checking things out. That's the foreman, right? And he's in charge really of a gang of about 10 to 12 people that are working on the exterior hull of this ship, right? And so there's all these wires stretched across. This again was skilled work, right? A lot of people had to start really learning how to weld and how to do it well. Right? Up until that point, what you really had was most ships were built with rivets, and actually when you go to the Iowa class, you still see that there's tons of rivets really in the Iowa itself, right? And welding is kind of a new technology, comes about in the 1930s. There's a number of reasons for that. The U.S. Navy was especially interested because welded hulls are lighter than riveted hulls.
Yes.
Because you don't have the overlaps between the plates, and plus, I mean, riveting, that's a tough job, and a skilled one in battleship construction, I will say. And so is welding. I mean, when you look at riveting, people who call this an unskilled trade, right? I mean, I always challenge when I say, do this, pick up a piece of metal that weighs about 2 pounds. Right, that is about melting hot, right? Pick that up with a pair of pliers, shove it into a hole, and hammer it flat with a pneumatic riveting gun, and then come back to me and talk about unskilled labor. Really, no, let's do that. Right? As far as welding is concerned, you got to be very careful with welding, because there's things that start to happen in welding that do not play a part in riveting. You mentioned weld shrinkage, which turned into a pretty serious problem actually during Iowa construction, because what happened was the weld shrinkage in Iowa bent the keel slightly to starboard. So, I mean, this is what tends to happen when you have an 880-foot hull, right? So they realized that at the Brooklyn Navy Yard, people were expecting heads to roll, but I mean, one way or another, they had to sort this out, right? So, it turned out that it was wall shrinkage, right?
Okay.
And they had to, unweld it or, take it apart and, that particular section of the keel, because you can't ride a battleship with a crooked keel, right?
No.
So they had to fix that mistake, and and it speaks to the importance. You got to know what you're doing when you're welding as well, right?
And
This is a skilled trade in and of itself.
right. And then also, I guess, in welding some of the armor, they ran into issues as well.
Oh yeah, armor is very, very difficult to weld, and they ran into this in Iowa as well as in New Jersey, down in Philadelphia. But in Iowa, this was a real serious problem. They had steel plates. They're called special treatment steel,
Yes.
um, and um, and they had an uneven carbon content in the Iowa plates. In the first batch that got delivered from Midvale Steel outside of Philadelphia, and so the steel manufacturer did not know just how much welding was going to be done on these armor plates, and so they put them into the Iowa, and then the weld seams started to peel off after a couple of days. They had to do it. I mean, that's the Navy for you as well, right? I mean, they do an investigation, they bring all these physicists, and, they bring in the chemists, all of this, and, establish a board investigation, all of this. And well, at the end of that was, they found out what was the particular problem, and they ordered different steel plates from Midvale, right? So there's a lot of this kind of stuff going on in terms of technological, development, in terms of experimentation that is happening on the drawing board in the shipyards. Right?
Lessons learned.
Now, lessons learned, lessons
Yeah.
learned. And here's another one. I mean, it cut the other way because, of course, the Iowa was under construction during the opening phase of the Pacific War. Right.
Right.
After Pearl Harbor, the U.S. Navy figured out, that most of the anti-aircraft guns were either insufficient in number or just no good in quality. The Iowa class had already been designed for 1.1 inch anti-aircraft guns,
Right.
and the Navy just said, "We're going to toss these. I mean, these are no good."
Yes.
And so they put Bofors guns, in instead, which was a whole different, set of problems. But in any event, so what that encapsulates is really the idea that that the ship design evolves while the ship is already under construction, and what that requires is an enormous amount of construction flexibility, really, on design flexibility. I mean, you're never going to standardize a battleship design. You're never going to be able to do that. The Navy is going to come in and they're going to say, "Oh, when Washington was dealing with Kashima, in Guadalcanal, right? I mean, there were issues. There were issues with the South Dakota class,
Right.
when their electricity failed."
Yeah, right.
The Battle of Guadalcanal. So, you got to figure this out. What's the problem?
Right.
Right? I mean, battleships are designed for combat, and not to carry coals to Newcastle. So right?
Yeah, exactly.
These are complicated fighting mechanisms, and so that is kind of what these shipyard workers had to be prepared for on a daily basis.
I would imagine the Brooklyn Navy Yard was sharing their experiences with the Philadelphia Navy Yard as they were moving along with New Iowa, and New Jersey was being built, of course, at the same time.
Yes, absolutely. Yes. And there was a design coordination group, because the design was actually handled at Brooklyn in the Navy Yard. This was one of the largest design organizations in American industry at the Brooklyn Navy Yard. And they developed the plans that was sent down to Philadelphia. And but there were always questions that the shop masters in Philadelphia had for the designers back in New York. So they'd establish a design coordination group uh, that did weekly visits. These guys coming up from Philly, going into Brooklyn, and having design coordination conferences. These shop masters, sometimes they put in 300-400 questions
Wow.
to the designers and naval architects and marine engineers. Right.
Sure. So I know Iowa, along with New Jersey, they were built in a remarkable 32 months. But apparently the urgency for battleships lessened because Wisconsin, they took 36 months, and then Missouri, 41 months. And I imagine they were probably looking more to have carriers and other types of ships rather than the battleships come out.
It's kind of an interesting debate within the U.S. Navy. Um, Traditionally, battleships were supposed to fight in the line of battle, all right, with other battleships and taking on enemy battleships. U.S. Navy doctrine kind of developed gradually in the 20s and 30s, and I think in a more sort of sophisticated way. And I think the Iowa class in some ways kind of encapsulates that, because this was a very fast ship.
Yes.
At one point, they said, the Iowa was clocked at 31 knots. That's very fast.
Oh, right.
It had actually the same set of engines, this exact same engine design as the Midway that you have down in San Diego, right? And
Yes.
the engines are exactly the same,
Right.
meaning that the Iowa class could theoretically, and in fact, eventually did sail with the fast carrier groups that wreaked havoc on the Imperial Navy, in the Pacific War from 43 onward. So, it is, again, I mean, in terms of developing these ships and building them, I mean, the expense is huge, right?
Yes.
There are challenges in between. But yeah, so in the end, it turns out that the Iowas were the last ones to be built. Uh, Program got cut down from 6 to 4.
Right.
Montana class got canceled entirely, and that
Okay.
was probably a good thing. I mean, the Montanas were probably too big. They didn't fit in the Panama Canal either.
Yes.
So,
That's
you
correct.
know,
Right.
actually the U.S. government was planning to build Supermax canal locks in Panama to fit the Montana class through that.
Oh,
That never happened. But
right.
nowadays we're kind of leaving it to other people to do these kinds of heavy industrial lifting jobs, right?
Sure.
But yeah. So Iowa was really the last one, and I think battleships at this point kind of had outlived their usefulness, except
Right.
perhaps in a role like within fast carrier groups.
Sure. And I know you just mentioned a little earlier the differences in the four Iowas. Or part of them are the engines, who they were constructed by. But there are some quirky differences in the battleships. And one of them I noted years ago is from Robert Sumrall's technical book on the Iowa, where the forward and aft transverse bulkheads that are protecting the armored citadel on the New Jersey and the Iowa, they're only 11.3 inches of Class A armor. But after the naval treaty restrictions fell apart in the early 40s, the Missouri and Wisconsin increased theirs to be 14.5 inches
Yes.
because they didn't have to worry about the weight, constructions.
Yeah. It demonstrates just the sheer extent to which battleship design was really influenced by diplomatic considerations, like in this particular case,
Yes.
right? The British will always be real sticklers when it came to keeping to treaty classifications, right? The Germans were always trying to cheat all the time. As far as displacement were concerned, I mean, they were subject to restrictions under Versailles Treaty, which was different. But yeah, so you kind of see the sheer extent to which the design of these ships was really
Constrained.
influenced by diplomatic considerations and by other things.
Sure. Sure.
So again, I mean, when you kind of look at the sheer amount of design, and workplace skills that went into these ships. It's
Right.
remarkable. If you want to go actually, and we got to start winding things down. We have another 6 minutes to go, but here we can just go through this quickly. The welder training at Brooklyn, right? This was done in the National Youth Administration. You kind of see, and this young guy, learns a lot more than fiddling with this dial that is putting the amps. Again, I mean, because the training that these guys went through was far more rigorous, really, than anything that you saw in the Kaiser Shipyards.
Interesting.
The next one is actually, it wasn't all work and no play. The Brooklyn Navy Yard, these guys actually did build the Iowa, but when they were not building Iowa, they were a top-notch basketball team from the Brooklyn Navy Yard. That won just about every title up and down the coast. Now, when you have a look at this guy, maybe for some of you this sounds familiar. Howard Zinn, who was a famous activist, historian, and all of that. But when he was 18 years old, he was not just a member of the Brooklyn Navy Yard basketball team. You kind of see him in the back, standing on your far right. He is one of those guys that built the Iowa, right? I was absolutely floored when I heard about this. I read a long oral history interview with Howard Zinn when he was an 18-year-old kid out of Brooklyn, and talked about the ways in which he was trained as a ship fitter, and that's actually a very skilled trade. And so he's a really interesting guy in that respect. Right. In any event, so he worked on the Iowa. You kind of see this here. Approaching completion at the Navy Yard. The picture that I wanted to leave you with is the last one. The next one here. Yes. So this is doing launch preparations, right? I was getting ready for launch, and I mean, we oftentimes see these pictures, photographs of ship launchings kind of used as a book title because, it seems to be such a big deal to kind of see, well, this is 36,000 tons of steel, right? That is going to be slipped into the water. Right. And so the big wigs that come up from Washington, with their champagne bottles and, and all of this. But the prep work that went into launching Iowa was stupendous. They spent 8 months preparing for this moment. Nobody had ever launched a ship this heavy from slipways. Right. This was the biggest, heaviest ship ever launched from an American slipway. The only thing that ever came close sits right in your neighborhood, and that is the Queen Mary in Long Beach. And what the American naval architects did, they went to Scotland, where Queen Mary was built at Clydeside, John Brown, that shipyard. And, because John Brown had done very, very detailed calculations how to launch that ship, the Queen Mary, in a very, very narrow river section. So, Iowa designers went to Clydebank, checked things out. Clydebank had, by the way, done a superb job. When they launched the Queen Mary, they were off by, in a launch path that was about 1,300 feet long, they were off by 2 feet. So, I mean, that's pretty remarkable. They used these calculations for the Iowa, and lo and behold, it went off without a hitch. So, and that is what I want to leave you with. We're going to have actually a quick video that I wanted to show you of the launching of the Iowa.
Great. Here's a treat for everybody. This is a
bigger by 10,000 tons than any United States warship afloat, the huge dreadnought Iowa is ready for launching 7 months ahead of schedule. The nation's First Lady, Mrs. Franklin D. Roosevelt, attends the wartime ceremony. The wife of Vice President Wallace sponsors the Iowa, named in honor of her native state. Down the ways, the mighty vessel rides to the sea. Armament and batteries a naval secret, the Iowa is said to be the most powerful capital ship ever launched.
And then the Missouri would have been right next to her, at least
That's right.
the lower deck.
Yes.
would be not-
And they did a good job. I mean, she did not slam into, what is that? The Manhattan Bridge, right in the back here.
Right.
And,
Yeah.
so, by the way, I mean, these launch ways that you see in front here,
Yes.
right at the bottom,
Right.
those had to be covered with, they did these calculations very accurately, 47 tons of soap and grease and sperm oil derived from sperm whales. Get this, right? You wanted to make sure that this ship would slide down these ways, but at the right speed. If you use too much grease, it was going to go too fast, and that would break the propeller shaft that extends inside that hull, right?
Right.
If you use too little, the ship would be stuck on the launchways, which was always a huge embarrassment to any shipbuilder who was, experienced that. All right.
Sure.
Thank you very much. And ready for questions.
Okay, here we go. Questions. And I just wanted to add, there are other warship and shipyards that are covered in your book too. And
Oh, yes. Thank you. Yes.
we maybe selfishly, spend a lot of time on the Iowas, but hopefully most of us enjoyed that. So,
Thank you.
okay.
Absolutely.
This is from one of our volunteers. What factors gave the country the political will to fund shipbuilding at over shipyards in between the wars and to build and operate our own merchant marine in such a large scale?
Mm-hmm. Thank you. Yes. And the short answer to that is FDR. Franklin Roosevelt, who was an absolute ship buff. He was also U.S. Assistant Secretary of the Navy in the First World War, had overseen and managed really the biggest shipbuilding program in American history up until that point. Was a big Navy fan. He traveled on board Iowa. He traveled on board Indianapolis, right?
Many other warships.
That was the president's ship. It was kind of the Air Force One of its day. Right?
Yeah, that's exactly.
It's FDR. And so when he became president in 1933, one of the first things that, people saying, oh, you got to do unemployment relief. He says, okay, let's do unemployment relief, but, let's kill two birds with one stone. How about we building a bunch of aircraft carriers potentially for, to contain the Japanese? So that was the birthplace, incidentally, then of the two aircraft carriers, the Yorktown class, Yorktown itself and Enterprise. Right? So FDR really put the shoulder to the wheel as far as naval shipbuilding is concerned. He had to balance this out. He didn't want to provoke the Japanese, but he wouldn't let them get away with nonsense either. That's one thing. The other thing is, FDR really pushed for establishment of the U.S. Maritime Commission in 1936 to really kind of wean American maritime transportation of British bottoms that carried so much of American foreign trade. So, though that is kind of the short answer to that. It's really Roosevelt who played a very significant part in this.
Interesting.
Mm-hmm.
So we're ready for the next question.
Mm-hmm.
I think they're going to post it. How did the architects and engineers factor into the structure of the ship, the firing of the 16-inch guns, basically what the pressure of the gun blast would do to the hull?
Mm-hmm. It was a huge problem, and I might add, as far as kind of building the hull itself was concerned, and the turrets, I mean, that was a never-ending horror story, because, well, organizationally, these turrets, they were designed by the Bureau of Ordnance, which was separate from the Bureau of Ships that handled the design of the hull and the engines. Turned out, because of a bureaucratic nightmare between these two bureaus, it turned out that the turret was 2 feet too big for the hull. The turret, had to, did not really, the turret that they had designed at the Bureau of Ordnance did not fit into that hull. They had to redesign the turret. Of course, everybody blamed each other, but yeah. So the turret design, was done relatively hastily, I must say, on the part of the Bureau of Ordnance. The turrets, when you kind of sorry. Okay, thank you. Yes, so yeah, I might as well talk about that, right? I mean, you kind of see that those are the openings here that eventually would receive the turrets, and those are the 16-inch gun turrets, right? This was a pretty serious problem, as far as the welding was concerned. The Japanese ran into that. The Japanese, what they did was they built the Mogami class heavy cruisers with what? That's 8-inch guns, right? Yes, 8-inch guns. When they fired those, all at the same time, that tore apart the weld seams. It's one of the reasons why the Japanese never introduced welding on a comparable scale like the Germans and the Americans. And but the Americans started to pay a lot of attention to the gun recoil, what effect that would have, how it would eventually produce problems, for the turret foundations, all of this. I mean, so the Summerall book has this somewhere where he says, the Iowa class was really so well designed that they would duplicate and triplicate backup systems everywhere. You never really knew if something broke, because there was always an instantaneous backup. I think that is true. For when you look at the bottom of the ship, I mean, that's a triple bottom, right? And that was really all designed with the idea in mind to make sure that hull could take the recoil from these enormous guns. Right? I mean, we're really talking about 16-inch guns.
Right.
Yeah.
Most definitely. Now the next question: how did the shipyards manage to build the 22 Essex class carriers so quickly?
Yes, well, okay, that's a very interesting story, the Essex class, because the lead yard that was responsible for that was Newport News in Virginia, and they're still in business. They're building the Ford class now, right?
Yes.
So the way Newport News got involved in carrier construction was they made basically a secret deal with two other shipyards. One was New York Ship in Camden, New Jersey, and the other one was Bethlehem in Fall River, Massachusetts. This they did in the 20s, where basically New York Ship said, we're going to only build light cruisers. Bethlehem Fall River said, we're only going to build heavy cruisers, and Newport News was going to build aircraft carriers, even though actually Newport News did not know the first thing about aircraft carriers, whereas actually Bethlehem had converted the Lexington, and New York Ship had converted Saratoga from battle cruisers to aircraft carriers. Newport News did not know the first thing about aircraft carriers really until the early 30s. That's when they started with the Ranger. By the way, this was a very corrupt deal. This kind of thing was not supposed to happen, where defense contractors are sitting around behind the scenes kind of sorting out who's going to build what. This was supposed to be competitive business. So Newport News, undermined the entire process, and that's how they got involved in in the in aircraft carrier construction. They managed then to get the contract for the Essex Class, which was really a follow-on to the Yorktown. The Newport News had done the Yorktown design, which was actually very good. It was a good ship. And it probably should not have been abandoned like she was, after Midway, but that's a separate story. So they incorporated a lot of these, lessons that they had learned. One thing, how did we manage to build so many of the Essex, right? One reason for that is because American aircraft carrier designers, and especially Newport News, did not include armored flight decks. British carriers had armored flight decks. And the reason for that is because the British were expecting to operate in the Mediterranean close to dive bomber bases, right? The Americans were not expecting to operate anywhere near in the Pacific the same number of enemy dive bomber bases. So they had unarmored flight decks. That is the Essex class. I think the Midway class was different. I think in Midway they started to incorporate, heavier armor. But that was one of the, because armor production is very, very difficult. It takes 6 to 9 months to forge one of those plates, and that slows things down. Aircraft carrier construction is a lot easier to be done actually than battleships, from a design and from construction standpoint, and from kind of standpoint of the supplies that go into these ships. Right? So, that's how they managed to build these relatively quickly. My book, I do want to make a plug, does actually have a whole, not an entire chapter, but another good 20 pages on how Independence class aircraft carriers were built in a very similar way to the Essex class, and the sheer extent to which subcontractors were involved in that process, really all across the United States, that produced parts, bleeder valves, turbines, forced draft blowers, things like that, for aircraft carriers. So if anybody wants to buy the book,
there you go.
There.
Very interesting.
Yeah.
There's one question. This is kind of a broad question, and the person is saying, sorry about this, but how did warship philosophy differ between the major powers?
Oh, thank you. Yes. Well, warship philosophy. For the interwar period, you can say that, everybody and their cousin really still believed in Mahan. That was, in the idea of a decisive battle. Mahan is sort of the high priest, really, of the concept of a decisive battle. The Japanese prepared for it. The Americans prepared for it. So did the British, because they lost, they don't say that to the British ever, that they lost Jutland, but, that they fought the Germans to a draw there, and they were eager to pull another Trafalgar. Right. Sure. Yes. And so he was in so many ways the high priest, Alfred there, Mahan, really, of battleship strategy and what you want to call it that way, philosophy. They all shared that. I think the Americans were more innovative in the use of independent carrier groups. The Americans were greatly interested in this. And, this is one of those things that to the credit, I don't like Admiral King, but, he was one of those guys that pushed for the concept of independent carrier groups very aggressively. And the Americans experimented with that quite significantly already in the 1929 fleet exercises. So, the Americans, I think, were to a degree at the forefront of conceptualizing carrier groups as independent forces. Everybody else sort of saw aircraft carriers as ships that would fight with, would protect the line of battle against enemy aircraft, or even like the British wanted to use them as spotter airplanes. Sure. That's not a very creative way to think about carriers. Right? The Americans, I think, were on the forefront of that. Yeah.
And yet the British went and bombed Toronto, which was preview of
surprise.
Go figure, right? Like,
Oh my God. Yeah. I mean, don't get the British started on Toronto. I mean,
yeah,
because, I mean, these were completely outdated aircraft, swordfish.
yes,
I, I mean, the British just, scratched their heads after they realized, oh my God, what, we disabled 3 Italian battleships,
right,
right? Uh,
right, yeah,
how exactly did we do that, right? And
yep,
yeah, and I think the Americans could have explained it to them pretty well. Because yeah, I think the Americans were ahead of other navies in terms of conceptualizing naval air power. The Germans were really no good at it. I mean, they didn't even have a line of battle really. They never managed to finish any aircraft carriers in the Second World
right,
War.
yeah,
Um, so in that way, no, I think the Americans kind of had an advantage really over other navies in that respect.
interesting.
Yeah.
There's one last question, and
Oh,
maybe we're running just a tad late, but we'll see
okay, I'm good.
if that's all right.
Yeah,
Um,
absolutely.
was there one or more warship production boards overseeing uh, the design and construction of these vessels?
Oh yeah. Yes, yes. So there was a huge controversy really brewing in the United States Navy over the design, and that started really with the North Carolina class. With the design of these ships, because the Navy, and especially what was back then the Bureau of Engineering, was pushing for a new propulsion concept that they called high pressure, high temperature engines. That, I mean, for the connoisseurs of these things, those were Curtis turbines, so the problem for the shipbuilders was that these turbines were going to be built they were going to be built by General Electric and Westinghouse, and not by the shipbuilders themselves. The shipbuilders, like Newport News and New York Ship and Bethlehem Fall River, when they built engines, they usually built turbine engines derived from Parsons, right? These were very traditional Parsons turbines, and the Navy didn't like those. The U.S. Navy did not like the Parsons turbines. There were some people, my book tells that story, there were some people in the Navy department that actually threatened Newport News if they were going to transmit any performance data about American Parsons turbines to the British, they would be prosecuted under the Espionage Act. This is how far the Navy went, really in the attempt to blackmail the shipbuilders into abandoning Parsons engines and putting all the eggs in the basket of Curtis engine, turbines.
Right.
In any event, that is kind of a controversy that played out in the battleship design workshop or group that got assembled by Navy Secretary, Assistant Navy Secretary Charles Edison, who was the son of Thomas Edison, by the way, and later on became governor of New Jersey. But he assembled the first battleship design group where these guys fought over particularly the design of the engine and of the turbines. And make a long story short, the shipbuilders lost that fight in that conversation. And but American battleships were better for it, really. Curtis engines were better. And even the British eventually admitted that grudgingly, but
Right.
they did.
Well, I did have one last question pop up, and then we will close for this afternoon's talk. And during World War I, there was a large number of publications published by the U.S. Shipping Board that were basically how-to manuals for steel shipbuilding companies.
Mhm.
Was there a comparable attempt to provide technical literature for the U.S. shipbuilding industry in World War II?
Thank you for asking that. Yes, I think that's a very important question. And the short answer to that is yes. There were some organizations that was really at the forefront of this. One was Bethlehem Steel, or Bethlehem Shipbuilding, which was a subdivision of Bethlehem Steel. And I must say, I mean, I learned an awful lot really about the engineering and the stuff out of those handbooks. Many of those were actually produced by, the naval builders within Bethlehem Shipbuilding at Fall River. So, a lot of the stuff that you read in those pamphlets is really applicable to naval shipbuilding. The other organization that did a lot of handbooks was Sun Shipbuilding in Chester, Pennsylvania, which was really America's premier tanker builder. And they were really in so many ways at the forefront of, for the connoisseurs, again, of these things, it's called, electric arc welding, and specifically submerged electric arc welding that was done, for not just tankers, but eventually the Liberty ships as well. And, that it's a highly automated process. Sun Ship really pioneered that in the 30s, and then kind of tried to teach it to Kaiser. And by the way, Kaiser was just so much better at all this publicity stuff. The Navy rolled eyes every time they heard the name Kaiser spoken. Veteran shipbuilders hated the guy because he was such a self-promoter and such a showboat. And, organizations like Sun Ship and like Bethlehem, they just went about their business and built good ships. That's kind of the bottom line. And taught Kaiser how to do these things. Kaiser always said, he introduced electric arc welding in American shipbuilding. That's nonsense, not true. He was just a good self-promoter.
Right.
Yeah.
Right.
Yeah.
Well, obviously, we could probably go on for several more hours, but thank you very much for spending this last hour with myself and the viewers. And I really, really applaud the efforts that you put into this book, and it really does bring to light a lot of incredible accomplishments that our American industries, accomplished during this World War II period. And I'm really excited and looking forward to reading the book. We're posting on here where you can order the book, as we mentioned early, the United States Naval Institute Press. And thank you all for joining us today, the viewers out there. Please remember to go to our Iowa Battleship, PacificBattleship.com website. We are conducting and have been able to manage to stay open with an outdoor tour. We've also just recently released and have placed online a virtual tour that's really incredible and fun to explore Iowa. And then also on our website, I've posted from my collection of photographs, many from the National Archives, construction photographs of Iowa being built, and that's under the history tab, and it'll say virtual artifacts. So you're welcome to go there as well and research some more and view some of the wonderful sites of these massive warships being built. So again, thanks everybody for joining us today. And again, thank you very, very much, Thomas. It was wonderful to hear all these different facts and factoids. I think we all enjoyed very much all these.
Thank you, Dave. Thank you very much.
Items.
My pleasure.
So everybody stay safe out there, and we hope we can do another presentation in the future, and we welcome any suggestions on topic matters that you might come up with. So bye-bye.